So today we are going to discuss about the 2010 A-level question, which is based on integration. This is going to be the question number 6. So let's get on directly with it. I'm most probably sure that you guys must have revised all the work by now, since the examination is a few months from now. And most importantly, I hope to explain the most basic things about integration using this question. So we'll be moving from the most basic to the most advanced, which is easy for you to understand, right? The integration question is usually, if we read it, it's a really moderate question, which requires a bit amount of hard work, and most importantly, the integration gives you 150 marks, which is really expensive, right? These 150 marks is very expensive and it's very precious. In your exam is also one of the most dangerous questions, which you can manage by practicing the questions and doing them again and again. So first of all, I'm going to write the question or do the question which is based on partial fractions. So if I start with the integral sign like this, and 2x 1 plus x squared 1 plus x squared dx. So now we have this partial fraction. So in order to solve this integration question, you got to solve this using partial fractions first, right? That is done in this way. So first of all, you put integration, and this is going to be the 2010 A-level question, right? And now I'm going to solve this using partial fractions first. 1 plus x squared plus 1 plus x squared, the whole thing squared, and in this one only the x is squared. So therefore we are going to solve this by saying ax plus b. I'm most probably sure that most of the students must have revised partial fractions, because you need the partial fractions knowledge in order for you to do this question as well. But basically what we do here is that we solve this in partial fractions. If you have the x squared here and you have a positive sign and something like this, then you should put ax plus b, because this cannot be solved into many factors, right? So therefore 1 plus x squared, you can write ax plus b as a partial fraction, and then below you put 1 plus x squared. Then you put plus sign here, and then you see a c d, and we have 1 plus x squared. So now, since you have all have written this down, the next thing which you got to consider is that we should solve this now. Now see, we have 2x here and we have 2x here. It's going to be ax plus b, and this should be 1 plus x squared plus c plus x plus 1 plus x squared plus d 1 plus x squared. This is the way you solve this. So when you do this, since we have to make the common denominator, and we do this, and then this left hand side denominator and the right hand side denominator gets cancelled off. So we are not going to write it. Anyone can understand it, right? Ax plus b, and then we put this one here, 1 plus x 1, and this, and 1 plus x squared dot b. So now what we should be doing is that we should find the coefficients in order to solve this. Coefficients. Before you write coefficients, I will make you understand what happens, right? So now we have 2x here, and then we should solve this, right? Ax plus b. I'll go in step by step method, because most of my students suggested that we should do it step by step. So I'm going to help you guys in understanding x squared plus c, and then you have this x cube, then you have plus x squared plus x plus 1 plus d 1 plus x squared and that. So now since you have solved up to here, now what we should be doing is that we should solve this one too. So 2x is equals to ax plus 2ax squared plus ax cubed plus b plus 2bx plus bx squared. C x cubed plus x squared plus x plus 1 plus d 1 plus x squared. Now since we have solved up here, now it's very easy for you to understand from this step onwards how to get the coefficients. So now solve this using the coefficients of x squared. Now first let's take x cubed. So here you have x cubed, here you have x cubed. So therefore 0 equals a plus c is the first equation you obtain. And the next question which you should do is that coefficients of x squared. So now in order for you to find the coefficient of x squared, you should first of all consider this x squared, this x squared, this x squared, and then this. Right. So 0 equals 2a, then you have b plus c plus d. Right. So now that you have found it, now what we should be doing is that we should mark this as the second equation. Now we should find the coefficients of x to the power 1. So x to the power 1 we have 2. First let's take 2 and then we have a plus 2b. Then we have c. Then we have d. No, right? We do not have d, we only have up to here. So now when you see this equation, we have said that a plus c is equal to 0. So therefore this a plus c should be equal to 0. Therefore 1 equals b. Therefore we found the value of b and substitute that value of b here, then you will get minus 1 equals, you can say that c equals minus a, so therefore we'll have a plus d. Right, so this is the equation a. So now we have already solved one equation, so therefore we can get it out. And now we should find the coefficients of x to the power 0. X to the power 0, so now we have b, we have d and c, b, c, d. b plus c plus d. Now since you have b plus such a equation, you can say that minus 1 equals c plus d is the equation b we obtained. So now we have obtained all 4 equations which is required. So now what we got to do is we got to substitute and find the values. So now you have this equation. So let's see how to solve it. Yeah, so now you can see that this c plus d is existing right here. So therefore, in place of c plus d, we can put minus 1, right? We can put minus 1. B plus d, c plus d equals minus 1. And then we found that b was 1 and 2a equals 0. So therefore, a is going to be equal to 0, right? So therefore, you can get the conclusion from that point. Right, so that is going to be equal to 0. So you can clearly see that d will be equals to 0. I see d will be equals to minus 1. D will be equals to minus 1. C will be also equals to 0. So now we have solved this using the partial fractions method, and now I'm going to write. We have found that b is equals to 1 over 1 plus x squared, and we found that d is minus 1, therefore we can put something like this. Therefore you have now solved the partial fraction, right? So that is about all the workings that you require to find. So this will be the partial fractions answer. And now what you got to do is that you got to solve these partial fractions now using integration, right? So that was the initial question. You got to solve this using partial fractions. This is the integration question. So now since we have this obtained, most of you will probably be able to understand now what we are going to do. So 1 plus 1 plus x squared dx minus 1 and 1 plus x squared. So let me take this off. This can be written, you can clearly see that 1 plus x squared is the value for tan inverse x. So when we differentiate tan inverse x, we get this above obtained value. So we have tan inverse x obtained, and the next thing which we got to do is 1 plus x squared, right? So tan inverse x plus 1 plus x squared, we can obtain that answer finally, and be sure to write that plus c, where c is the arbitrary constant. Arbitrary So now you have achieved most of the marks which you require for this question. This first question, if it's really big, which has a certain amount of simplifications, you can clearly see that it has a decent amount of marks. So let's see how much marks you get for this question. So you can see clearly that you get 40 marks for this question. You get 40 marks for this question. So you have achieved 40 marks and there is 110 marks more to go, right? And now let's move on to the next question, which is going to be to show you. Nice. So they have given that you should find and show that it's given to show that, which is a very easy question. So they have said that I is going to be equals to E ax cos bx. cos bx dot dx, and you have the integral sign here. And similarly, they are given that j is going to be equals to ebx, right? eax dot sine bx dot dx. Get that dot out, right? So we get confused if we have dot, we do not multiply, it's just a sign existing in the specific sum. So now we got to consider this question which says these are the values I and j. And first of all, when you see such a question, you got to understand what we should do. So in here we have one here and one here. So therefore, right, you cannot integrate without using by parts method. So first of all, if you consider by parts method, what you got to think here is that you got to take this, you can take anything, right? Matters what you take and how you think. So we can take EAX. Since the answer is given in positive kind of way, we should consider it in a positive way, because if we integrate cos bx, we will get sin bx, which is a positive value. But if we integrate EAX and differentiate cos bx, then we will get a negative value. So that's the problem here. So therefore, we should integrate in a positive way. So EAX du by dx is equals to a dot EAX. So now you have integrated this part, and the next thing which you got to do is that you got to take dv over dx is going to be equals to cos bx. V equals 1 over v sin bx. So now using the by parts formula, what you got to do is that EAX over b sin bx minus, so then you put the integral sign and put 1 over b sin bx dot a dot e a x dx. So if you're wondering what this equation which we have used is actually the by parts formula, which is going to be given like this. First of all, you write uv minus v du by dx and dx there. So this is what we have done. We have put u and v. We have v here and then v here, and then you have du by dx applied here. So it's easy for you to understand from this point on. And now to solve this, you can indicate EAX dot b sin bx minus a over v sin bx EAX dx. So you know this, right? Sin bx is j. Take that as j, and then you have a common term b EAX sin bx minus a over sin bx dot ex and dx here, and now you take this b to the other side, so therefore you will get ab ai, you get bi, and once you take this to this side you get this, so therefore this is going to be plus a j is equals to e a x sin b x. So therefore you have the first answer which they have asked. So you can clearly see that how easy this question is. if you have the right practice and if you have the right knowledge on how to manage this question, to how to think logically, what to get first and what to get secondly, then you can easily manage this question, which I'm pretty sure you can. So let's see how much marks you get for this question. So you get 10 marks for this part. So not much, but it counts a lot, right? So even though it's a very small mark, you get 10 marks for this question, right? So even though it's not much, it counts a lot for your final mark, right? Say you get 74, this is very important to get you to 75, right? Okay, so now what we should be doing is that we should solve this in this way. So now that we have solved this way, the next thing which we have to do is put, now they have given a minus sign, therefore minus minus plus becomes positive and goes to the other side becomes negative. Have that sense and take u as cos dx this time. I'm sure it will come. So u equals cos dx, du by dx is equals to b minus sine b bx dv by dx is going to be equals to using the bypass formula. I'm going to write uv. The product of uv is going to be 1 over a e ax dot cos bx minus 1 over a e ax dot b sin bx dx, and this minus sign into minus sign will be positive, so therefore this will become positive. So therefore now what you got to indicate here is j, this is going to be equals to I, right? So now you can clearly see that we have b here and b here. We can take it out. We can take b out because b and a are constants. So this a goes to this side. Therefore we can say ai is equals to eax cos bx plus b dot I, b dot j, right? B dot j. So therefore ai minus bj is going to be equals to eax cos bx, and that's it. So now that you have proved the second one, get a total mark of 10 marks for this simplification, right? You get a total of 10 marks for that part. So now what you got to do is basically for these two equations you got to apply simultaneous equations. So I'll be using simultaneous equations. So that's one also easy part. So now let's solve this first equation and the second equation. For this one, in order to eliminate that, we can multiply this the first equation multiplied by b plus the second equation multiplied by a. So therefore we will get b squared I minus plus ab j plus a squared I minus abj, and for the answers also you got to put this is going to be, we can take like this, It's easy if you consider like that. So this one should be multiplied by b sine bx plus a cos bx. So now you can cancel this and this out, and then you get I equals e ax b sine bx plus a cos bx over a squared plus b squared. So similarly, do not complicate it, right? For the next one, take 1, multiply it by a, subtract it by 2, and multiply 2 by b. Then you will be able to get j. So that is one easy part, anyone of you can understand. So I'll give that as homework and do the rest for the next day, right? So I hope that you learned something today. So that's about it for today's class. I've been doing for the past 2 hours, right? And the revision class is also a success, a huge success. So the theory is completely done, and now this is going to be the revision class, right? So hope you got something out from it, and most importantly, be sure to support and share, right?